Hi Year 11s, so this is for you, this is Bivariate data. Oh, it's a little bit echoey in here, I'm in the science lab, as I'm sure you can tell by the periodic table. So what I've done is I've really just kind of photocopied the notes that I've given you again, and I'm just going to talk you through it. I was going to write out other examples, but these ones are just as good really, so let's go through these together. So looking up the top, so we've done our scatter plot. If you can't remember how to do a scatter plot, please look at the notes. Hopefully you know that by now, or just Google scatter plots. That should help you. Maybe I'll give you a link or something on the Twitter site. Okay, I need to be able to see this too. All right, so what we're doing is we're talking about finding our quadrants. So once we've got A, B, C, and D, which we'll talk about how to find in a minute, remember what you want. So A, B, C, and D, so you, whoops, I'm on the wrong side of the page. So your values up here. This is not the values of the dots in the quadrants, it's how many dots there are, okay? So you just want to count the amount of dots. You don't actually want to work out what they're worth or add them together or anything like that, because that's just wrong. Okay, so Q correlation, let's start with that. Actually, let's not start with that. Let's start with the bottom bit. How to draw the quadrants A, B, C, and D, all right? Let's start with this bit. So what you do is you find the median. So remember, the median is the exact middle of the x values. Oops, using the paper. So you need to find the exact middle, the median of the x values, and draw a line. Okay, straight through it. So use that dot, draw a line right through the dot. For this type of thing, you'll need a ruler. That makes it much more accurate. Then you need to find the median, the exact middle of the y values, and draw a line straight through that. Okay, and that is how you get your two lines. So it ends up looking like it does up the top. So it'll end up looking like this with your four quadrants, okay? Then you'll know how many dots you've got in each, right? And how to find that Q correlation is just by using this formula up here. Okay, so let's talk a little bit about that. The value of Q is always between +1 and -1, okay? So remember that, always between 1 and 1. If Q is positive, a positive relationship exists between x and y. That is, whatever the variables are, whether they're, you know, height and shoe size, which is what we're going to do on the test, or could be anything, okay? So whatever those two variables are, it's talking about the relationship. So if Q is positive, there's a positive relationship between x and y. So if x is small, so is y. And when x is big, so is y. So what you're talking about is the two things relate to each other, and they have a causal relationship, which we'll get into. Okay, the closer the Q correlation is to +1, the stronger the relationship between x and y is. We call this a strong positive relationship. Okay, we're going to get into more of that. Hopefully that makes sense to you. So the closer the number is to 1, the stronger the relationship between the two things is, all right? So yeah, the higher the Q number, the stronger the relationship. The opposite of the above is also true. The closer the Q correlation is to -1, the weaker the relationship between x and y is. We call this a strong negative relationship, okay? So if it's closer to -1, it's a strong negative relationship. If it's close to +1, it's a strong positive relationship. That's easy to remember because if it's negative, it's negative, and if it's positive, it's positive. So that bit's kind of easy, thankfully. And then I've just said down the bottom, to find the formula, count how many dots there are in each quadrant. Oh, and I also forgot to say that. Don't include the median you drew the lines through, okay? So remember how we drew those lines through the median dots earlier? Do not include those dots when you're counting how many dots there are in the quadrants, right? Good. All right, let's move on. Next one. Oh, well, not next one, it's the same thing, but okay. So, the strength of association. So sometimes you're going to need to find the strength of association. What you need to do is figure out your Q value, which you've already done, okay? Then what you're going to say is if it's between 0 and 0.5, it's weak. If it's between 0.5 and 0.8, it's moderate. And if it's between 0.8 and 1, it's strong, okay? So that's how you tell what type of association, whether it's weak, moderate, or strong. Let's just read that paragraph. This measures exactly how, that's not what it says. This measures how strongly the two variables impact on each other. For example, height and weight, or height and shoe size, which is like what we're going to do. So we're measuring how strongly they impact. So generally speaking, someone taller is going to have bigger feet, right? So we're assuming it'll be a strong positive relationship. Okay, keep reading. A strong positive, that's not what it says again. A strong relationship does not mean one thing causes another, okay? So we're not saying because you're tall, you have large feet, but we're saying that there's a causal relationship between them. So it's likely that a tall person will have big feet, but it's not necessarily true. You know, some small people have really big feet, or some tall people would have small feet. So you can't say that they cause each other, but they have a causal relationship, okay? So we can tell that the two things are related, but yeah, one does not cause the other directly. And then at the bottom, just look at page 158, and there's the example. So there were those different graphs. They had different types of relationships and just what that would look like. That's a good thing to know, because if you have a look at something and you realise it's probably got a strong positive relationship, and then your Q correlation is like -0.5, you're going to know you've got the wrong answer, okay? So it's a good idea to have a look at those, and so you can kind of roughly guess and check your own answers. All right, what's the next one? Whoa, okay, here's an example of one. Oh, it's so hard to see around this. I need to be able to see my screen. Okay, so here's an example. So what we've got here is we've got two sets of results. So someone took an English test and a science test, and these are the results from those people, okay? Let's move it back a little bit. So we've got science and English. There's that table up the top, and then we've plotted it on the scatter plot. And then what we've done is we've found the median of X. So when the numbers are in order, which they aren't necessarily in order, the English ones and the science ones first, I haven't actually written that bit down, but you'll need to actually put it in order, okay? So write it out separately, because the median, yeah, they have to be in order to do this. So remember, the median is X plus, oh, what am I doing? My brain is not working. N plus 1 over 2. So there are 11 numbers there. If you count them all, if you count all these up, there's 11 of them. So 11 plus 1 is 12, divided by 2 is 6. The sixth value happens to be 6 when the numbers are all in order, which, you know, certainly won't normally be the case. That just happens to be this time. Then the Y median, same thing. There are 11 of those. So 11 plus 1 is 12, divided by 2 is 6. So we need the sixth value, which also happens to be 6. So, you know, that was probably not a great example, but you get the point. So once again, when the numbers are in order, this is how it works. So what we want to do is find our Q correlation. So we use our formula, A plus C minus B plus D over A plus B plus C plus D. So what we need to do is go back to our little scatter plot and count how many dots. How many dots are in A? Well, there's 2 in A. So what am I pointing at? This is A. There are 2 dots in A. In B, there are 3 dots in B. There are 2 dots in C. And there are also 2 dots in D, okay? So all we've done is replace A, B, C, and D with 2, 2, 3, and 2. So we've got 2 plus 2 minus 3 plus 2 over 2 plus 3 plus 2 plus 2. So you solve that and you end up with -1 over 9, and then all you do is turn that into a decimal, okay? We always want decimals when we're talking about a Q correlation. We don't want fractions. So -1 over 9 as a decimal, is 0.11 or -0.11, all right? And if we go back to this, it's between 0 and 0.5, so it's weak, okay? So we say it's weak. So it's a weak negative relationship. So we can see there's not really, and you would expect that from looking at the scatter plot. No,